Just
A very stupid question. What is the policy if I wear this? I'm wearing this.
You may not be, okay, if you are presented, you can still end up photographed.
Okay. But I can still wear it.
You can still wear it. You are allowed.
There is a meaning for the.
Yes.
I pick it randomly.
No, it has
Because
very
it's a
specific
Ferrari
meaning.
color, right? Ferrari color.
The red says, please don't photograph.
Really?
But the policy says, but note, presenters will get photographed. That's just the way it is.
But in the IETF open meeting, there was one of the presenters was wearing this, and then the photographer asked him, take it out.
The professional photographers will try to be more careful because they will try to actually go through and remove pictures with people with the red. So he's saying, you're the presenter. But that's, the policy actually says presenters can be photographed, but
And still videotaped and uploaded to YouTube.
yep, you're gonna show up. You're on, that's, the thing is, you will be on the video record and it will show up and the chairs will show up.
Okay, no matter
No matter what. So
Yeah.
okay.
You don't need to take it off. But it's, yeah, the red lanyards. It's amazing how many people don't notice the instruction that says, no, that's, it has meaning. It has meaning.
Another Italian. You see another Italian.
It's a Ferrari color.
Just check if all the slides are there.
Yep, let's get this low on the show.
Hello, good morning, everyone. So welcome to the Lisp working group. I'm gonna start. This is the not well, as usual, which basically means everything we say here today is a contribution to the IETF. I guess as well the joke we were making a couple of minutes ago, but anyway. The usual pointers. I'm Luigi Iannone, Joel Alpern, we are the two co-chairs. Padma, our secretary, Wasim is missing, the other secretary. We will see what happened to him. And I would like to go just as usual on the working group updates. So this is the exact same slide like in Bangkok, which doesn't mean we didn't make any progress, just doesn't show up yet on the data tracker. So there are a bunch of documents that are on hold, but the main documents on which we were working between Bangkok and now are the two BIS documents and LispSec. So on the BIS documents, we had a thorough security review. We had some delays going back and forth on the emails. We had a meeting with Ben this week, and I guess everything is sorted out. Albert will give a summary. In the meantime, LispSec, we put it on working group last call, because one of the comments from the ISG was if it's difficult to evaluate the level of security of the BIS documents when part of the protection security is in the LispSec document. So it would be good to have everything together to review. Okay, so we put in working group last call. Actually, Ben right away make a good review, and so there are a few changes that will be done to the document, but yeah, I'm pretty happy because basically I think we sorted out all the problems, and at the end Lisp is better than before. Okay, hopefully we will progress quickly and move to other stuff. Concerning the agenda today, so we have Albert with the updates on the BIS document and LispSec, I guess, as well. A quick update on the Young model. These are the two working group documents. And then, so we had a request from Dino on the decent Lisp mapping system, and Sharon about distributed geospatial Lisp blackboard for automotive. It's gonna do a demo. Pretty cool stuff, I have to say. So the original agenda had then 25 minutes discussion time. Okay, after this, we will open the mic, but if there are no big discussion, we have two late requests about a slot, which is Lisp Uberlay, Alberto asked it, and Lisp anonymity, Padma asked. So 10 minutes each, if time's allowed, you share what is remaining. Yes,
this is Dino. Don't you think Lisp anonymity should go higher in the agenda since it's a working group document?
Okay, came in as a late request.
Exactly. We can switch it with Uberlay, but it doesn't get that much. I mean, so.
Yeah, no, it's fine.
Okay.
Yeah, no problem. Makes sense.
Oh,
We would
okay.
have time for everything else.
Okay. So we can start. So Albert.
Okay, so I'm going to present typically I come here and I present what we have changed on the document. Now I'm going to explain what we plan to change, which is the plan ahead. This was what we was discussed with the reviewers, particularly with the security reviewers. And the title is wrong because it's actually 6830, 6833 BIS plus LispSec. So this is a summary of the list. This is a list that summarizes pretty much all the comments that we got from the security review and how we are going to address them. So the first one is incremental deployment of LispSec, which means what happens when you have a deployment where some ETRs are non-LispSec capable and some other ETRs are LispSec capable. So how can you signal this information back to the ITR? The 2, 3, 4, and 5 are security of data plane mechanisms, which each of them has some security concerns, which was raised by the reviewers. So for instance, gleaning, this is well known. It can lead to spoofing of gleaning, can lead to redirection of on-off-path attacks. Same with LSB. For the econons, the nonce is too short, and this allows off-path attackers to DOS a Lisp site. And map versioning, which an off-path attacker can spoof it to try to prevent signaling updates. Then the 6 is they ask for a clarification on the anti-replay protection that we have for map register. Then 7 is that we are using the keys directly, the private share key directly to sign the map register, and this has some security concerns, which we are addressing. And finally, it's rather a clarification, which is how we are protecting against anti-replay attacks, map request and map reply. So the first one, now I'm going to go through all of them, and I'm going to explain which is how we plan to fix them. So the first one is, this is the scenario, right? So you have a non-Lisp sec capable ETR, and that needs to, and then you have an ITR that is map requesting through Lisp sec and EID. Now, how can this ITR understand that this non-Lisp sec capable ETR is non-Lisp sec? And this has to be done in a secure way. Otherwise, we are open to a downgrade attack. And the way we have decided to address it is, you will have the standard map request, which will travel back to down to the map server, and then the map server knows that the ETR is non-Lisp sec capable because it has map registered without the S bit, and then it will send a negative map reply with a new bit, which is called the E bit, which is called ETR consign, back to the ITR. This is protected by Lisp sec. And now it's up to the local policy of the ITR to decide whether to send a new map request without Lisp sec or decide not to communicate. But the interesting thing is that that's a way to the ITR to get secure information that the ITR is non-Lisp sec and prevent downgrade attacks. So this is where the new E bit goes. And well, the spec is a little bit more complex because you have more corner cases with proxy and so on. And this is pretty much the machinery that we plan to include into Lisp sec to cover all these cases. So all the details are in the slides if you want to read them. So then issues 2, 3, 4, and 5, which are security of data plane mechanism. That's something that we discussed with Ben, and there is a verbal agreement, which only means that there is a verbal agreement. We need to write that into the document and they need to review it again. But what we agreed is that we will state in the definition of gleaning LSB economics and map versioning that those mechanisms should not be used on a scenario, on a public internet scenario. I think that we need to work a little bit more on the writing, on how we say that. And I think that you, Luigi, had a good way of putting it, but I cannot remember exactly your wording. Something like, I don't remember. It was not public in the public internet, but it's, well, we will. But the message is this one.
Yeah.
It was something like, yeah, do not use it if it's not a closed and trusted environment, something like that. Okay, we need to work the wording, but that's pretty much the message.
Yeah, so there were two parts. One is don't use it in an untrusted environment. So you use it only in trusted environment, and the deployer should be aware of the risks related to this mechanism. This was the 2 parts. I don't remember exactly the wording, but what we will.
Yeah, here is the word. I repeat. Use can be considered in closed and trusted environment with suitable trust. That's
okay. Thanks, Fabio. So this will be included also in the upcoming versions of the document. Then they also asked for a clarification on how we are protecting against anti-replay attacks in map register, which is something that it is already on the text, and I'm just refreshing it or explaining it again. So in this case, the attack is that an ETR is map registering with a particular nonce, then an attacker can intercept this entire message and replay it and register it with the same EID to airlock mapping. So what we propose, and that's already written, is that the nonce now becomes a sequence number, and each map register you need to state a new nonce.
This is Dino, and Ben suggested that when you start off that the nonce doesn't start at 0, it starts with a random number.
Yeah, randomly. So you start with random nonce, and then for each map register, you increase the nonce by 1, and then both map server and ETR, they need to keep state of the last nonce they use. Now, if an attacker intercepts this map register message, and it replays it, it will have the same nonce, which will not be accepted by the map server because the map server only accepts nonces which are higher than the last sim. Okay, then what happens if the ETR reboots or if the map server reboots? What we say is that the nonce share the state of the nonce share fates with the private share key, which means that if you cannot keep track of the nonce after a reboot, what you need to do is you need to rekey and use a new key. Okay, then the next one. This is the security concern came by. I'm not an expert on security, but more or less I understand that if you use directly a private share key to sign the map register, then an attacker could collect many map registers which have been signed and use some sort of brute force math, I guess, to try to brute force the private share key. And then it is a good security practice to not use directly the private share key, but rather to use a key derivation function, which is pretty much that will provide you the key that you will actually use to sign. And the way we will compute this key is you take this key derivation function, which I understand it's pretty much like an HMAC, so it's not very simple. Then you take the nonce, you take a string, which are in our case we have decided that it will be map register authentication, plus the private share key. You add everything together, you perform this function over all this information, and then you get the key that you will actually use to sign the map register.
This is Dino. So what we haven't talked about is how do we make this interoperate with the existing stuff? We should do that offline.
Okay.
No, we did. Yeah.
Fabio Maino, Cisco. Yeah, no, I think we
Get
had
closer to the microphone.
yeah, in the various exchanges of email, we consider interoperability with the old version, and I think it's your next slide because is where you, or maybe the next one? No, okay, no, then it's not in the slide. You're right that it's not in the slide, but we talk about it. So the way to make it interoperable with existing implementation is that today we define the algorithm ID that is there in the packet. And the algorithm ID today is specifying only the HMAC function that we use in the map register. So basically, in the map register message, there is the authentication data that is there, and the algorithm ID is telling you that you should use SHA-256, whatever. We can define a new algorithm IDs that are, say, specifying not only the HMAC function, but also the KDF function. So then we define, I think we have defined right now algorithm ID 0, 1, and 2. We'll define algorithm ID 3 that is saying this will use HMAC SHA-256 and KDF, HKDF from RFC, I don't remember the number, 6831 or whatever number it is. And that is basically specifying that for that new key ID, algorithm ID mechanism, the ETR will have to do not only the HMAC computation, but before that, it will have to do the key derivation function. And this is extensible because we can define future algorithms that, you know, whenever somebody will decide that SHA-256 or HKDF so-and-so is not good, we can define a new one.
This is Dino. So Fabio, can we do that with like a high order bit? Because if we set the high order bit, then we should say, let's use KDF for all the existing hashes that are identified. So if the high order bit's 0, it works as today. The high order bit set and the low order bit say SHA-256, that means use SHA-256 with KDF.
Yeah, I didn't thought about that. Yeah, I think it's a once in a time. I mean, we have defined already, I think, HMAC 96 and HMAC SHA-128 that are 1 and 2. Maybe we can define, rather than defining 3, we define, you know, we set to 1 the high order bit. But I don't think that will become a, I mean, we can decide, rather than assigning 3, we can assign...
I mean, rather than having 2x values, You just set the high order bit, and then any new HMAC you add later can run in non-KDF mode and KDF.
Yeah, but also I don't want to burn two entries in there for things that in the future we'll not use. I mean, it is very clear today that we will define HMAC SHA-128 plus HKDF, and that's it. In the future, all the other will not be. So we can do that. I mean, rather than defining 3 for HMAC plus HKDF, since HMAC SHA-128 was 2, we define 1, 2 hexadecimal rather than, and yeah, it might be it's a small optimization, but we can do it.
Okay. Thanks. So basically, we interoperate with legacy implementations by saying HMAC whatever, KDF none.
Yeah.
Okay. Yeah. I still don't get the high bit order, but sooner or later I will understand that. Okay, and this was also this is the last item. It's a clarification to the reviewers because there is some overloaded semantics on the word nonce. And at some point it was written that the nonce was providing anti-replay protection for map request, map reply. And that's actually not true. And with Lisp-sec, what actually it is providing anti-replay protection for map request, map reply is the fact that we are using one-time key that is used only once. And that after you receive the map reply, you have to discard the nonce and the one-time key that you use for this map request, map reply exchange. And then, which means that the nonce is a random number that it is only used to index the map request. So when you send a map request, then you receive a map reply, you don't know which is the corresponding map request, and you use that nonce to know which was. But it is not providing any kind of security protection. And that's it. Is there any comment or question?
Just for clarification to understand this, so you throw away the pair, but you can keep the nonce value. It's just the association that you throw away, or everything?
So you throw away everything.
Okay.
And then if you need to send a new map request, then you will generate a new nonce and a new one-time key.
Okay. Thanks.
I think, what is providing anti-reply protection is the fact that the one-time key is one time. So I generate a one-time key, it's a big number, it's 128 bits. I'll do the map request, map reply exchange, replies come back. I take, I check the integrity protection, and then I discard the one-time key. The nonce is now providing only an index, so that when I receive the map reply back, I can basically look up which one-time key I had used to protect that key. The nonce, I think what is 64-bit or 32-bit? 64. Okay, it's 64-bit. It still has to be randomly generated because you don't want to use the same nonce, because otherwise you will point to the same one-time key. But the security, I mean the property of anti-replay is not in the nonce, is in the one-time key, right? Let's make a difference, because otherwise the nonce would have had to be much bigger. I think one way we worded during the conversation with Ben was that if Lisp-sec is not enabled, the nonce provide a limited anti-reply protection. I think we could use a wording like that, and that leaves open
for off-path attackers.
Yeah.
So I just wanted to address Luigi's question. So the nonce OTK pair in both the implementations of Lisp I've done, it's also used as a data structure for rate limiting map requests. In lieu of the map reply coming back, you want a rate limit. So what happens is if you send a map request and you don't get a map reply, you're going to at some point later send another map request. You send it with the same nonce with a different OTK, or you can be a new two-tuple pair. So you have to consider those things too, because the rate limiting is really important, right?
Yeah. And I think there is text, right? That is, I don't remember, but I think there is text that is saying that rate limiting is important.
Yeah, and now we have an exponential backup
Yeah.
for the rate limit, for the retransmissions.
Right, exactly. What this thing does is that, yeah, right. Because if you get if the attacker is sending you map replies with a nonce that you have sent, you will still look up the OTK and do so. There is still the possibility of a DOS, but rate limiting is what ultimately prevents the DOS.
On the other hand, the attacker could just be in the a man in the middle and just dropping the map request, causing you to retransmit to see if you're using the same one-time key. I mean, one time is a relative term, right? Is it one time for this destination query, or is it for each individual map request? Should be the latter.
Yeah.
Should be the latter, yeah.
Yeah. One time is one time.
Crystal clear, right?
Okay.
Okay. No, thank you very much. So, young model. The
A really quick update on the YAM model. So yeah, since the last version we published, we basically took care of Dino's comments on the wording, as you can see on the slide. We also took care of the comment. I think it was coming from Joel about the instance ID 0. That is the one that is used for the internet and the default verb. And then we also make sure to align the key with what is defined in RFC 6833bis. That now is split into two. In the YAM model, it was only one. And we have added the possibility to have the key per XTRID in the map server, so you can have a key per the whole EAD prefix, or you can have a key per EAD prefix per XTRID. And we have done minor editorial changes through the YAM model. We have been fixing some typos and whatnot. So this is only a small update. Now, what we would like to clarify with the chairs in the working group, we believe that we are now aligned with the latest version of the BIS documents. So what are the next steps? Should we start the working group last call? Also, the document needs a young doctor review. I'm not completely sure of the process, but I believe that is up to the chairs to ask for a young doctor review. So what should we do now?
I would personally prefer to ask for a young doctor review right away. We'll do it, and then we go for a working group last call.
That sounds good to me.
If he gives a green light, it's okay. So
Yeah, if you guys
just
think
not
it's fine.
to overlap discussion between changes between young doctor review and working group last call, or later
exactly.
on IETF.
That's what I wanted to know from you guys. What you think is best?
I would say
This is Dino. So this current Yang model has features that correspond to the proposed standard documents.
Yeah.
Nothing more or less. Is that right?
Hope so.
Yeah.
I think.
It has been aligned with the proposed standard. That's the idea.
That's what we've been trying to do.
Yeah.
I mean, there's existing working group documents that may define new types. And so I'm just wondering if it includes it or doesn't.
Our intention is to be perfectly aligned with this proposed standard. And if you guys find something that is not,
PS Yang model.
Yeah.
So we can have a PS Yang model.
Exactly.
PS spec.
but Dino, if you see something that is not, I mean, let us know and we'll fix it.
I just wanted to be consistent.
Okay.
Yep.
Yeah.
We're
Okay.
all on that page.
Okay. That's
We
it.
will
Yeah.
proceed that way.
I mean,
Yeah.
let's be honest here. It has all this instance ID stuff in there, and that's all defined in the VPN document, which is a working group document that's not going to propose standard. I mean, I don't want to complicate things, but
But I mean but in RFC 6833bis, isn't any reference to instance ID?
Vaguely.
we don't talk about instance ID explicitly other than it's an extended EID lookup in the mapping system, and the mapping system documents support a a
Yeah, but the
tutorial.
mapping system, PS documents do support the field.
Yeah.
And so it's okay to have them in the Yang model because it's not like we're modeling a field that is not in the PS document. I think we're walking the line the right way. We're trying to keep it consistent.
For once, we're walking the line the right way.
Okay. Listen, you use your own device? Yeah. As you like.
No different than normal.
So you can just flip this back. You're there, except that you gotta.
Okay, I'm going to talk about this a relatively new idea of a decentralized mapping system. So just briefly, a draft status. We created the document back in July of last year, and we presented it. I presented it in London about 1 year ago, and then Colin presented it in Montreal, the -01 draft. The -202 draft, we just did an update last November, adding a pull-based mechanism to the already push-based mechanism that we have, and we'll explain that in a second. And then we just did a quick update because I did an implementation of it, and so we did a quick update reflecting some details there. So what's the problem statement? Well, what if we could have XTRs? Everything's flickering. Okay. What if we can have XTRs that didn't need to depend on a third party? And what if these XTRs could be multi-homed and roamed around to inform each other about RLOCs? What if the Lisp XTRs could be their own mapping system and didn't have to depend on a third party? So we can basically build a democratized, decentralized control plane. And throughout the presentation, where you see green, we're talking about EIDs. Where you see red, we're talking about RLOC addresses. So the use cases are basically cryptocurrency or blockchain applications take advantage of this decentralized approach. Emergency networking, where you don't have access to the capital I internet, but you have connectivity among devices, can use this sort of feature. Plug and play VPN networking, when you don't want to depend on anything else. You come up with a container system with microservices and then come down. It'd be nice if they could find their own mappings to each other. By having a decentralized space network, can we do this by having people rent or sell bandwidth and resources on satellites to do a decentralized internet in space? And then just general shareable economy apps. So just to go through real quickly what today's mapping system looks like for people that are not familiar. You know, we have all these Lisp sites that have EID space, and then we have these Lisp XTRs, which are data plane nodes that actually move the packets, encapsulate from one site to the other. But to find the locations of the EIDs, they have to look at a mapping system to find out what the EID to RLOC mapping is. And the way it works simply is that these sites here have these EID prefixes in many different address families, and then they basically register to one or more, usually more than one, for redundancy to their map servers. The map servers are connected together with a Lisp mapping system, either using Lisp DDT or Lisp alt. So if you just take that last picture and you just squeeze these sites like that, because they have this backdoor wireless connectivity, how would the mapping system be useful if the links broke? So let's say, you know, you're in New Orleans and Katrina comes and you have no connection to the internet. How are people going to be able to find each other? Note that these are all wireless devices here moving around. They may have new RLOCs. They may be connecting from 5G to or Wi-Fi or back and forth, and they need to be able to talk to each other. How do they encapsulate without the mapping system? So that's the problem we're trying to solve here. So we have a push-based model that we presented last year, and we actually demoed it for you. We're going to repeat that just to show you the complete design and how we fit in the push model and the pull model. But what if each XTR could be a map server? And what if each XTR could map register to each other's XTRs? So they're not only a data plane node, they're also part of the mapping system. And the mapping system would always be synchronized because the updates are being pushed to everybody who needs to use them, okay? And then the XTR could be a resolver for itself. Since you're getting the mappings, you don't have to send a map request externally. Since everybody is synchronized, you send a local map request to yourself or just do a memory lookup to yourself. In the push-based model, what we want is maybe a subset of those XTRs could be co-located and be map resolvers and map servers. Not all of them because of scale. This is very much similar to blockchain where you have a set of seed nodes that bootstrap all the peers. And if we know a common seed node, if Padma and I are using Luigi as a seed node, we can be attached to this peer-to-peer network at the application layer. And because of Luigi, Padma and I could discover each other. So that's kind of the idea here with the pull-based model as well. Of course, the registrations would be sharded, just like they are today. And the EID would be used as an input to a hash function to select where map requests and map registers go. And they'd have to go to the same place or it wouldn't work. And then we have redundancy through the DNS level of indirection. And I'll show that in a second.
It sounds like a couple of issues, and they may be addressed on later slides. But one, if you want stability, something gets strange when you suddenly add another server because he can't actually take responsibility for any addresses, because anything that would hash to him now must have hashed to somebody else before. So there seems to be a problem with adding and subtracting things if you require that the function is permanently stable.
We were able to get that to work.
Well,
So stay tuned.
okay, if that's on another slide, that's fine. The other one
absolutely
is there's a philosophical, what determines who's allowed to participate in these things?
Right.
Is there a slide on that?
I will address that. Yes.
Okay.
There's a slide that I
It will serve as a hook to address it. Thank you.
So let's look at the push-based system first. A consolidated mapping system is defined by a multicast group address. So everybody that wants to use the same mapping system to have this be able to get access to the same mappings are identified by this group address. And then the XTRs are part of the mapping system that are part of that mapping system join that multicast group. And then map registers are sent to the group. All XTRs will then receive all mappings. And then we can get efficient distribution. If the underlay supports multicast, then really each of these map or XTRs only have to send one pack and it gets distributed for the underlay. And if not, we can use head-end replication that's already part of the data plane in Lisp. And the map request has very low latency, like I said, because the lookups are done locally because you have a synchronized database. And like I said, the XTRs build and send exactly one map register for N XTRs. Now, what that means is that the XTR or the control plane module that's sending a map request only builds one and basically sends it down to the data plane. If the data plane knows that there's underlay multicast, then one actually goes out on the network and gets replicated in the network. Otherwise, the data plane head-end replicates, but it creates a multicast or multi-participant service model at the control plane. And management's really simplified, no different than a link state protocol where you can go to one node and find out the entire topology because it's all a synchronized database. So here's an example. We have these, a set of XTRs on the left-hand side that are part of one mapping system and a set of XTRs on the right-hand side. And I just used IPv4 on the left side and IPv6 on the right side, but they would basically be joined to 224.111 and push around their individual mappings. So all of them would have these mappings, and likewise on the right-hand side. So let's look at a pull-based mapping system and see how that can work. Well, what we thought is that if a map server sets are defined with a DNS name prefix, and then the EID is hashed to give you this modulus index.
Let's be clear. Prefix in this case means dotted suffix.
Yes.
It's a portion in the way we actually read DNS, starting with a dot and it's common thereafter. Is that that's what you're saying?
It's a DNS. a DNS prefix. The reason we call it a DNS prefix is because it's a DNS name, and then we will prefix the modulus index to it. I'll get to it on the next slide.
But the
Stay
type
tuned.
that's common is the DNS suffix, not the DNS
Suffix.
prefix.
This is true. Yes. Yes.
And it's dot delimited, right?
It's oh yeah, absolutely. Yeah. It's
Well-
a domain name, right? It's
Yeah.
a domain zone.
That's
yeah.
what I was trying to
Yeah,
make
okay.
sure.
Got it.
Because I've run into people who think you can do other things in DNS that really don't work.
Right. Well, the statement is technically accurate because the map server set is a prefix to a DNS suffix. So it is correct. Okay. Stay tuned. Just hold on. I know you're anxious, Joel.
No, I'm not anxious about it. It's,
That's okay. It's great to be anxious. Right. So the modulus index then selects this DNS name, and it basically on what I just said. And then the DNS name has multiple A records for each map server. And map registers and map requests go to the same map server set. And what's interesting about the pull-based system is we fixed the bug that was identified in previous presentations where we had a problem bootstrapping the push-based system because we use the mapping system to do the group joining. But if you need to use the mapping system to do the group joining, how do you, to make the mapping system real, you have this kind of circular dependency if you don't statically configure it. So we think the pull-based system could actually bootstrap the push-based system. And then what's interesting about the pull-based system is it doesn't have to connect all the map servers together. So you don't need these mapping database transport systems like DDT and ALT. The pull-based system could actually be used if you want to build a centralized implementation as well. But stay tuned. So here's an example of a pull-based system. Let's say we have these 8 map servers and we put them in 4 map server sets. MS1 and MS2 are together. So if you hash an EID and you get a modulus 0 or you hash it, you take it mod 4 because the modulus index is 4 here, you would prepend 0 to the suffix mslispers.net and you get those 2A records back. So we see we have an organization like this where these map servers are not synchronized with each other, they don't connect each other, there's no hierarchy on top that connects them together. So for instance, this XTR1 that wanted to register this /24 here would hash that character string with the instance ID and then do it modulus 4 and get a value of 0. And so we'll do a DNS lookup. It could do it ahead of time or when it needs it of 0.ms.lispers.net. The DNS system returns 1111 and 2222. And since it's a map register, it gets sent to both places. So you have your redundancy. Similar on the right-hand side for an IPv6 address, say its index was 3, it would register to 7 and 8. Now let's say a map request was being sent. Let's say XTR also has some IPv4 going on and it wants to look up 1.1.1 in the mapping system. It would actually hash the same way, so it's always taken to where the registration is.
is
So we
the
don't-
hash on the prefix, does the hash include the prefix length? Because
You
the
can
example, you show a map register with hashes, but the lookup doesn't know what the prefix length is.
So we added something in the latest draft called a hash mask. And the hash masks are high order bits that are common between the lookup and the registration. So here, if you look at it close enough, the hash mask could be the high order 16 bits, which would be the same. Now it's
So you have
working-
to have a system-wide hash mask
that could be advertised as
that
well, yeah.
everybody knows somehow, and everybody uses for their registration hash and for their lookup hash, and all registrations have to be that length or longer.
Right. Now, in cases where you're using 1/128s and /32s, like the XTR is co-located with the host, then it's one and the same. And you could use the entire thing.
If you know that everybody's registering /32s,
Yeah.
you can use a /32 of IPv4. But if some people are using /24s, you better not do the hash on the
Absolutely.
/32.
We're finding most of the Lisp use cases now are being put very close to the host, not even one hop away, but either inside the container or the hypervisor. So it's supporting a per host sort of thing because people want the mobility and therefore,
Well,
you know,
When you're
Because-
using it for mobility, I get that, but that's
Oh.
not the only use case we claim it's applicable to.
absolutely. That's why we have the hash mask.
Okay.
Okay, so so that's the algorithms, and I have an implementation of both of them, and I'm just going to give you a brief demo. A demo means just a bunch of screenshots. It'll be really quick, and then I'll just get off the stage. So in this push-based demo, we showed this in Montreal, or I guess maybe London. I don't think Colin did it, but anyways, we have 3 containers running the Lispers.NET code, and we have a Docker bridge that's not doing multicast because we wanted to show head-end replication done at the data plane. But we've certainly demoed it with using underlay multicast. The XTRs are doing the head-end replication, and the XTRs register an IPv4 EID prefix and a name EID. That's what the demo does. And if we just go here, those are the 3 XTRs, N1, N2, and N3. They all have the same information. They advertise their /32 in their name, and that just shows you it's synchronized. Now, what's interesting about the green box here, it shows that this group is being operated on the group address 224.111. So each of these XTRs have joined that, and so the data plane knows to replicate to each one of these RLOCs so they can get the information. Okay, so let me show you the pull-based demo. This is one map resolver, one MRMS container simulating those 8 map servers that I showed in the previous example. And then I have one ITR container that's map registering for a variety of EIDs, and then one ITR container that's sending a map request. Of course, the DNS prefix is MS, the DNS suffix, okay, there, you got me, Joel. This should say DNS suffix is ms.lispers.net, and the modulus is for. So this is an example. If you did a get host by name on the 0.ms.lispers.net, you would get these 2 addresses. Of course, they're RLOCs, and they have to be routable by the underlying internet. Same with 1 dot, 2 dot, 3 dot.
So the corollary is that if you lose all of the servers which are taking care of a particular modulus, nobody can register to anything that hashes to that, and nobody can look up anything that hashes to that.
Just like in today's mapping system too. If all map servers are down today, the map requests go through DDT. They come down to they black hole when they try to go to this.
Currently, there's a relationship between the map server providers and the customers who are making use of them. There's somebody to ask.
Yes.
In this system, there is a much looser relationship.
Yeah,
between
that's
the
true.
two.
And
And that's not a fatal flaw. I'm not saying that.
I agree
but
100%.
we need to be aware of what the limitations are.
Yeah, in the DDT model, it was great because we understood BGP peering and how agreements are between different organizations, but that still complicates things. Now these things could be run loosely coupled, but you have to, you as a mapping service provider have to know that, sorry, that's not my hash index. You have to go to my competitor to figure out the problem. Yeah, so. Okay, this just shows you the map server that all these things are being registered. So what I tried registering was some IPv4 addresses just for fun. I support E.164 telephone numbers in the system. So I wanted to try that to see where we hash to a MAC address, SCOM and G entries. These are all the EID types that we could support, IPv6 addresses, so forth and so on. This is just showing you that they all got to the mapping system, to the MRMS container. So this is the ETR sending map registers. You see all those green entries are basically different EID types. Oh, including distinguished names to be registered to, I call it distinguished names because that's the AFI. And then you see that basically we just do the hash and we assign these different indexes. And then when you see these things going into 0.ms.lispers.net, you know you have to send them to both A records that are associated with that. And you see for .1, you're sending to 3 and 4, 5 and 6, 7 and 8. So that's the map registering side. Now when the ITR sends map requests, okay, here's the lookup for 1.1.1. It's going to use 1, and then when you look up 2 it's going to use 0. Okay. Can't remember why I circled that, but I wanted to make some point about that, and I don't know what exactly it was. But anyways, I'll let you know later and tell you on the list. And that's it. Questions, comments? Tomatoes?
I have a couple of clarification questions. I mean, don't you have here a huge service discovery problem at the beginning if you have to know to whom you can talk to?
No, that's the whole point is
It's decentralized.
you
Did you-
configure the suffix, and once you want to send a register, you hash it, and that construction of the DNS name is allowing you to do that resource discovery.
Yes, this leads me to the second question. You started the motivation telling if Katerina comes and wipes out every connection to XTR, magically the DNS is still working.
There's
I mean, you have a dependency there.
no, you run
Yeah,
you run a local DNS in that case. This is a
the
this
same
is
way
a-
you can run
this
a
is a
local
local
mapping system. I mean, there is a dependency there because you say, I don't have access to the mapping server anymore, any of it. But do you rely on another infrastructure? And if you lose both,
no, you're
lost.
relying on a protocol, not a global infrastructure. Today, when you bring up containers, a container system that's completely isolated, you can use DNS names because it implements its own version of DNS, right? Its own
Yeah, but
localized.
we are talking about the devices, not containers.
I'm talking about the same thing too. Same. Doesn't matter.
A few questions and then we'll move on.
Yeah, this is Albert. Can you go to slide number 12 so I understand a little bit better how this works? Slide number 12, if you don't mind. If it's difficult, don't worry.
It's a question of latency. We're almost there. Okay.
Okay, so what you do is, so when you have a map request, you hash the EID,
Yeah.
and then out of the hash, you know the name, the DNS name over which to look up, and then you have the IP of the map server to query, right?
Right.
Okay. So you are trusting the DNS. You are trusting the DNS for authentication of EIDs, right?
You're using another level of indirection by using the DNS naming system to give you these A records, which are IP addresses of map servers. Yes.
Yeah. Okay. Thank you.
These could be Etsy host entries. They can be statically configured in your configuration. But if they're statically configured, then you don't have that dynamic resource discovery thing.
No, just to add a point to that too. I mean, part of the infrastructural design of this is actually to use some forms of distributed ledger. So the domain
Part of
name
what? I lost the word.
distributed ledger, or kind of a more shared cryptographic database where the trust of it comes by the resource input required to create it. So you can do key value lookups as far as DNS lookups or anything associated with that in that ledger itself so that it can be self-contained. So the ledger can also help maintain those trustable, I guess, aspects because
Look,
the mathematics and resource input required.
Either we need to say that or we need to not be dependent on it in the draft. I mean,
Yeah, of course.
none of this, well, you can make it work with a ledger. We've done this before of, we can make it work with this or that or the other thing. I'm not criticizing you. I'm not objecting to using
No, of
distributed
course.
ledger, but we need to be clear in the drafts
Yeah.
about what we're requiring. Dino didn't say one word in his presentation about a distributed
No,
ledger.
I agree 100. This specific draft was more so getting the infrastructural components of how the distributed mapping system would work. All these other little intricacies as far as like DNS or blockchain or anything else are kind of, I guess, secondary to that. But I guess we could maybe do some modifications to it and include some distributed ledger in there. To kind of,
If you want to, I mean, I actually would prefer that we keep our technologies separate and didn't have a
Okay.
dependence, but that's a personal prejudice,
Yeah.
not a chair's preference.
Yeah.
Yeah, so, you want to keep these things decoupled, but if they can provide value to each other, that's good. But we have to also be concerned about circular dependencies, right?
You just tell me slide, then you want directly to go to the webpage?
Hi, everybody. I'm going to talk about Lisp for mobility networks and mobility as in cars, scooters, pedestrians. If you can click on broken. and zoom in. And this for mobility, it's not going to be the trivial thing, VPNs, moving nodes. Therefore, I need this demo to sort of clarify. Yeah. So, yeah, if you go back to the slide, what you can see here in this map, and you'll be able to see it maybe later on my computer, is a tiling of every meter of every road, making it every meter in every road addressable using a standard called H3, using hexagon. It's a hierarchical standard. If you zoom in, you go from big hexagons, 1 square kilometers, very big hexagons to 1 square meter or 60 centimeters. So having these addressable entities as part of the road is why we're going to use Lisp, and I'm going to explain why in vehicle-to-vehicle networks, why do we want vehicles to talk to polygons instead of other vehicles? Okay, why do we want this indirection? And why this indirection involves this geospatial partition, and why this partition is in the ID space, what is it good for? So, all right, so vehicle-to-vehicle, vehicle-to-infrastructure is there to improve safety on the road, on the shared road, so that traffic lights, cat eyes on the roads, other cars will respond between what we do, so avoid accidents, basically. However, the adoption of vehicle-to-vehicle networks in the last decade has been very, very slow. Not good. Why? First of all, it's the start was simple. Just share GPS vectors, okay, between cars. The result is, or those who did play with it, is that every car gets a bunch of this about every other car around it. It's useless. And if you want to share better annotations, it's the interoperability of what do you share. Did you see some obstacle? Did you see a jaywalker? Do you see a blocked car? This is very hard to do interoperability-wise. So the industry is kind of stuck now in a war of layer 2. Who's going to operate the wireless infrastructure? Is it DSRC, Wi-Fi, municipalities, or Gov, or is going to be the cellular carrier with LTE, 5G, and they fight over the same spectrum. But the logical aspect of the network is completely unsolved. The reason we confronted with it earlier than the OEM car manufacturers is because we actually have, if not the largest, one of the largest vehicle-to-vehicle network out there, simply because of the way we went to market. So what we did is we paired the iPhone of a driver with a very cheap HD camera, like a $50 camera. It's like this small thing, and it can pair with the built-in cameras of the car. So it's very easy to give away a lot of cameras and have eyes on every meter of every road all the time. So we did that, and we put a few tens of thousands in every market we went into, and we got to like New York, Bay Area, Israel, Chicago, and then we got to experiment. Okay, now we have these eyes on the road. We have not just the camera, we have AI annotations. Half the company is AI, machine vision. We see things. How can we communicate? And part of this giveaway of all these cameras to these drivers, which host them very nicely, by the way, because it serves them well for deductibles and insurance and one-click claims and things like that. So they keep it well-tuned, focused on the road, paired to their iPhone with point-to-point Wi-Fi. So the insurance companies wanted to see some ADAS assisted driving safety features, and it was very easy to come up with many. Okay, and first one was highways in New York slowdowns. You know you ride on the highway and it's suddenly slow, and then it moves afterwards. I mean, but the slowdown is there for a while, and it's a very dangerous situation because if you're not focused, then you get these pileups. Especially if it's icy, you see it in the last minute, you hit the brakes, you start to twirl. It's a major source of pretty bad accidents. It's very easy to annotate. You drive, and suddenly the brake lights in front of you lit like Christmas trees. Now you want to tell people behind you. How do you do that? With vehicle to vehicle, you start to play lacrosse with other drivers, and you need to find drivers you're interoperable with. And it's not a very good way to start warning people about a very, very clear hazard which you clearly identify, and you can clearly give people 20, 30-second heads up so they can start to slow down. And there are many examples like it. So we went to an indirection model, which is the car that sees a slowdown, the car that sees a jaywalker, the car that sees a blockage, somebody unloading goods to a shop and will block your lane, will not tell it to any other car, but will tell it to the virtual tile of the road. And that has a unique annotation, has a unique address, IEID. So this annotation, which is part of a BDD enumeration standard, in this hexagon ID. I can snap to a hexagon ID, to a meter, not some jittery GPS. And therefore, I'm sending a message to a tile. So what better approach to communicate between these EIDs and EIDs than an overlay, map-assisted overlay, Lisp. So this is how we want to use Lisp, and we're actually using. We're converted a vehicle-to-vehicle architecture, which was like gaming architecture, peer-to-peer, to a Lisp-based indirection. All right. So one second.
Sorry.
So we're not sharing peer-to-peer. There's no point. Interoperability, and we want it open, is too difficult. Instead, we communicate through in-network state. The state is in EID space, represented by H3 IDs, 64-bit hierarchical codes, and it says PXDRs. I was shot already. No, it's RTR. I will show it. My bag. And EIDs publish subscribes to HID in order to get. So how does it work?
So before you go on,
yes.
I just want to make sure I've understood what you just said, because if I'm seeing something, probably other people are wondering what this looks like. Not in Lisp terms for the moment, is
Yes.
you've created a database
Yes.
indexed by an ID per tile,
Right.
and you're storing in the database the reports from every car that has a meaningful report about this tile,
Correct.
presumably with some currency, so you don't store
Correct.
irrelevant data.
Correct.
And then anybody who's interested in this set of tiles subscribes to it, so presumably as the car moves forward, it subscribes to the set of tiles that correspond to in front of it in the road.
Exactly. Just like
And
cellular
then
handover.
you're using the Lisp mechanisms as the mechanism for registering that you have information, putting information in. The Lisp subscribe mechanism is a way of getting the information out of this database. Is that a paraphrase?
No, the information about the road's not in the mapping system. So the systems are moving around.
Oh, the mapping system is used so I can talk to the right tile, because this is very geospatial.
Oh, so there is a conceptually it's not really a server per tile, but there's conceptually a server per tile.
Yes.
So when you do the EID lookup, you get the address of the,
Exactly.
you get the name, the address of the server which is responsible for that data, or the database key for that. Okay.
Exactly. It's actually a server per big tile that contains the many.
Doesn't
contacts.
matter what your granularity of server is.
Correct.
The EID lookup gives me
That's
who I should talk to get.
Exactly. That's
Okay. I missed that subtlety.
Where you should talk. Who you already know because of the EID.
Okay, just we can put the picture so I can explain.
Actually, no.
Okay,
I
go
would
ahead.
argue that you should.
Okay,
Can you click on?
the question is like, GPS is not really precise. So
Right.
normally, how do I know within which tile I'm located? This is about triangulation between antennas, whatever. Then is the description or the identifier of a tile, is it like mapping ID? Is it like an index in a database? So how do I map to this?
Yes, so that's a good question. So in order to publish an annotation, I saw this, I have to be 1 meter accurate, which GPS is not.
Correct.
But the way I annotate is through machine vision, which can be use localization to better snap to SAT and give me the 1 meter. So to publish, I need very good technology. To subscribe, that's not the case. I can be just a normal navigation app, and when I go into a cell, I need to get a dump of the next 20 seconds. So I need to get a heads up, and then I can locate myself, but where the hazard is on the map. So I will let the navigation or whatever correct the GPS as best it can, but the hazard position on the map is correct.
Well, but that would seem to have the risk that if I'm the driver who's using the data, if I'm on the service road for the highway and the highway is congested, I may get the report that there is congestion in front of me when there isn't. Now, if it's only viewed as informative, that's probably not fatal. But if I get told it's clear in front of me because it thinks I'm on the side road when I'm actually on the highway, that could be a serious problem because I won't react in advance.
The goal of the blackboard, okay, is to communicate where is the congestion. The responsibility of the client is to use the best information you can. Okay.
Fair enough.
So you want a better client, put a better gear there, right?
So are there some thoughts? So we always had the problem with, say, with Lisp with pre-roaming. So predicting where I'm heading for. So is there some idea that if I have all the hexagons and I know I'm going on the street and I maybe, like me, I'm from Germany, I'm going 280 kilometers per hour.
Yeah.
So is there a way to pre-roam that I can already encapsulate to the next?
Yeah, 20 seconds. So
Okay.
your client is supposed to prefetch your next 20 seconds. So in town, it's probably the next block, or I'm going to turn. Who is crossing the road, which I cannot see well because it's raining, things like that.
Cool.
While you're out of town, if you drive 90 kilometers per hour,
It's boring.
it's about 500 meters for you, or if anybody is flying then it's more. But it's up to you to prefetch the cells that you're going to get into.
Pretty cool.
Okay?
I just had one question. So do you have some kind of reputation? Because if you have multiple cars who are actually giving
Absolutely.
different information.
Absolutely, because you publish and you correct what you see because of your in-car AI. Then when you publish, you also sum up and may correct different annotations from different cars.
It strikes me, and I probably contributed to this, we're diving into a lot of details of navigation systems, information collection systems, which are all related to either the underlying database or to the application on the car, navigating car. I think because we wanted to give some other people time, we should focus on how Lisp is being used for this.
Correct.
It's really tempting. We're all engineers. We want to go refine all the rest of it. And Sharon would appreciate the feedback.
Yeah.
But we have a focus here.
Yeah, Shri Gundavelli. I think it's a great work. Thanks for that.
Oh, we
So-
still have to get to the next.
Yeah, it's just it's already great. Yeah. So I'm trying to still understand. So let's take the case of a pedestrian walking on the road, right?
Right.
How exactly would that be used? Let's say I'm driving and there's a pedestrian and the previous car detects that and you store that information in some whatever that you call it that, right? How do I subscribe for that event?
Okay, so here in this picture you see an example. This is a simple dash cam paired with AI, but it's traffic going this way.
Yeah.
Okay, it sees that the car here is stuck. Okay? So it puts in the hexagon that here's a blockage. Okay?
Okay.
Even though it didn't affect him, but he saw it. The blockage has an impact. So this is also nice functions of the service. And if you don't get it, you can traverse that very easily just by bitmask. So you see the impact. The impact is then said, okay, this is dangerous territory. Okay? So who subscribes to it? These cars. These cars go into this cell, just like in cellular, just like in there. And then they get a dump of the state of the hexagons which are in their future. Who else? These cat eyes may also subscribe. They don't move, but they subscribe to the sensor always. And they can start reflect with active LED, yellow, and things like that.
So maybe one more related. How does it, we are trying to address the same thing using BSM data. If you look at the SAE messaging, BSM, basic safety messages, right?
Yes.
So how does that compare to this? Actually, I'm just curious about that.
So what we did is we took 3 standards, okay?
Yeah.
H3, Lisp, and BDD, which Berkeley Deep Drive.
Guys,
Which is
I'm sorry to interrupt you.
Sorry.
This is
No,
too
maybe
much
that's-
details,
sure.
and we are running really
Yeah,
late.
no, this is-
Maybe
yeah.
you take it offline.
Okay.
Colin, you have a
Sure.
clarification question, a quick question.
Yeah, I was just going with the question if you want to do a server per granular cell, or as we were discussing earlier, but I was wondering what the opposition to having it be kind of more a localized mesh network be, because you solve latency issues and you have the mobility issues solved with not traversal with Lisp.
So
If there's any opposition to that
localized
idea.
mesh, real mesh is not feasible because it doesn't turn around corners. So you need anyway towers. So it's anyway in direction. We say it's also a layer 3 indirect.
Okay.
Okay. All right. So what is the Lisp usage? Okay. So the EADs and the HIDs are EID space. EADs can publish after snap to hex an annotation, HID state, EAD source, RTR1 dest. Okay, the RTR means, okay, he looks up.
Sharon, I think it's better to say who's assigned the EIDs, who is the RTR,
Okay.
and map it to the thing you said previously on your.
These are cars. Okay, they're roaming around. They're connected to the edge of that metro area based on load density, things like that. Pretty random which one, but low latency. And then this car sees something. Okay, it needs to tell Tile that it saw this thing there. 64-bit where, 64-bit what. So it sends it encapsulated to its home RTR, which then looks up the RLOC of this tile. Okay, so you can look up the mapping system. There's about 10 million tiles in every metro. Okay, and discovering which one is our road is also part of the network ongoing, and which one are just fields and buildings. But they're registered. Those of our road are registered here. And using the mapping system, you get the RLOC and get to XTR3, which is the bit switch in where the process that has the functions and the state of the HID. So this is how I talk to the tile. By talking to the tile, I'm also letting everybody know that I'm behind RTR1, and that also gets into the mapping system. Okay? Why do they need to know where I am? Because nobody's going to talk to me, but the tile is going to talk to me. And here the idea is that we update every second, and in 5G and native broadcast, we can update 10 times a second without a toll to the RF. But for now, every second. And the states, which is about 15, 1600 bytes of the next 20 seconds. Okay? So the multicast goes, the channel is HID1, preferably signal 3 gets to, okay, it's the next one. Sorry. Okay. gets to RTR1, RTR2, and then either native broadcast or unicast machine gun broadcast to the cars. Okay? All right. So just examples. This car is pulling out of this driveway. So EID1 sees it. It updates HID2, which broadcasts to EID3, which drives here and had no clue this is happening. Okay.
Quick question.
Very quick, Dino.
So you're making an architectural decision that 1 and 3 should not talk directly?
Yeah.
Yeah, okay.
Yeah,
And,
because there's so many types of those. Every car maker, every model, every navigation app,
okay, fine.
every car gadget.
So,
too difficult.
there'll be latency because it's taking
Yeah,
a
the
haircut.
latency is,
But
yeah.
are these hexagons pretty small where, the latency is reduced because of the distance?
So the latency impact is the hexagons are very micro partitioned. Therefore, the blocking factor is very low. That doesn't contribute to latency. It's very well partitioned. What does is typically the access network. So today, if I'm running on Amazon Edge, then it's 300 milliseconds. If I push it to Equinix Metro, it's 30 milliseconds.
The point is, I think, let me put it differently. As far as I can tell, you're not trying to solve. Car in front of me has suddenly stopped. Other sensors, other mechanisms. You're trying to solve the problem of there's a problem that's already occurred that I can tell you about slowly, gives you enough warning to react.
Correct.
Different class of problem, different latency issues, different.
Correct.
You simplify a lot of problems by focusing on a problem that we can solve.
Exactly. Exactly. No, actually, there's no use of networking in 1 second ahead by Mobileye and any of these. It just doesn't work.
Can you say again what HID is or
H hexagon ID. It's the H3. I recommend to look at H3 and the functions open source. Okay.
Yeah, this is
By the way, Sharon, I just got notified. People in the back can't hear you. You need to be closer
which
to your
back?
microphone.
Oh, okay. Yes, sorry.
This is Albert. So this is a Lisp question. So the way I understand it is that you need a way to query for the location of an hexagon.
You need to talk to the hexagon, and you need to know where the RLOC of that hexagon is.
Yeah, this is why.
This server is its babysitter.
So not limited to, but I understand that what you need is so you send the position of the hexagon, the smallest one, and you need the mapping system to be able to tell you, okay, this specific hexagon, the smaller granularity, it is located in that server.
Yes, exactly. And there is a question here we won't double click on.
Eric Nordmark, another Lisp question. Do you care at all about authenticating the source EID of the packet?
Yeah, absolutely. This is part of even registering and getting the RTR that you can talk to.
So you need to have that binding to the geo coordinates effectively.
Yeah, you need to AAA before getting the RTR, and every time you get to a new RTR, every time out. Absolutely.
Okay.
I'll ask you to go quickly through the other slides because we are running.
We're out of time.
Okay, this is stuff we see: potholes, traffic light meters, blah blah blah. Never mind that. You can look at. This is you can click. This is something. Yeah, we can show it. It doesn't matter. Okay, use case sharing in town annotations through beyond line of sight across garbage trucks. All this stuff that hurts commute. Double park Jericho.
Actually, jaywalkers are probably too fast, but that's.
Jaywalker, if you saw them, 20 seconds. They walk with the iPhone, it's terrible. Scooter.
You mean with Android they are quicker?
But anyway,
out of town stuff. Yeah, okay, you get the gist. And the idea is that we have an ability to go into production really quickly because they have a large footprint. Right now it's in tens of thousands per market. It's going to be hundreds of thousands per market. And we can be ahead of the market in understanding things that OEM are just don't know what to do about it yet. Okay? And this is a test that we did in an Air Force base. This is actually the blockage that picked up by this traffic, emerge, and beyond line of sight, and it's very clear. You go, you see that the map sees everything, but when you go into a car this height, you don't see anything. And then you get a heads up, and it's really helpful. Maintenance use case, just for people to finance these cameras and distribute them, really helps. Incoming, we can show you crazy videos. All right.
Offline, maybe.
Offline.
People clearly found it interesting, but we need to move on.
Thank you very much, Sharon. Maybe next time you give us an update, we allocate more time. So we have only 10 minutes left, which means we can accommodate one of the two requests.
They have agreed on who's doing it. Okay.
Yeah.
I- you're up.
Let me put on the slide.
Okay, so I'll be really fast on this one. So the document right now is in version 5, and the latest change we made is a very small change just for a clarification, because one sentence actually was looking really the contrary of what we were doing, so we wanted to fix that. Actually, what is EID and ODBT is about is that we want to talk about if you have a permanent EID and you have it for a long time, once somebody looks you up, they can actually eventually track where you are. So the whole point is we want to make EID private and non-trackable. And the way of doing this, we also don't want to use a very heavy weight, more of encryption, etc. But where it is really useful is in your mobility cases or cases where you're talking with somebody that you're an untrusted peer that you don't want him to know your EID for some reason. So how do we achieve this is really hiding in a crowd, or rather here it's in a pool of aggressors. So basically what will happen is that we use them a little bit like the credit cards. You use it once and you throw it. So the next time somebody, even if he stored it and tried to get back, he's got no guarantee that it's actually you. And then we recycle it. But the draft is very simple draft. Is actually specifying that range of IDs that we can do, or, and actually giving other suggestions of how we could actually create those hash to have those ephemeral EIDs and cycle through it. So one thing that is important that we're going to make in a new correction of the draft that's going to go out, maybe tomorrow or something, which not only we want to say that we can have several of these ephemeral EIDs on per interface, but also you might be thinking of cases where you may be using one specific one for each one of your peers. But we know that EIDs are meant to have limited time usage, or else it degrades to the normal case where you have a long-lived identifier. But one correction that we're making in the draft right now is to make sure that they're not mutually inclusive. You may have the normal long-lived EID, but you actually use an ephemeral EID to talk with specific peers. So there's no big changes in the Lisp protocol. The draft is actually really relying on existing mechanisms. The draft is really to show the reservation of the pool and collision avoidance recommendations. And so we would like to ask for this document to be in working group last call. It's been there for quite some time. It's been pretty stable. It's pretty simple. So there. Any question, comments?
Any comment?
So I want to make a comment on the last call, and please, very friendly. I mean, many of us have been incredibly busy in addressing the RFCB's review process. Now LISSEC is being added, and really that is sucking out all of the air from the room. And I mean, I honestly didn't have time to do the proper review of this document, and I will not have time for the next 3 months, I suspect. So my suggestion is really can we wait one cycle so that, we can focus all the energy of the group into, trying to push this thing through and then going forward.
Okay,
Let me add one more thing. So one nice effect of this pain we've been going through is that now there are at least a couple of guys in the SecDir, Ben and Eric, that are knowledgeable of Lisp. So I think this in time will come back because they now understand well the Lisp protocol and they have clearly a very strong security background. So I think that if we take a little more time, we can, focus more energy on this one. That's my only comment.
So, first of
Also,
all,
frankly, I would not ask Deborah to handle anything that was not necessary for getting us to PS until we have finished with the ISG on the PS ones, because
so I hear you guys, and actually I want to say thanks for bulldozing the way for us later. But we actually was going to ask for this for last call in Bangkok, and then I hold it one cycle by myself. So this is the second cycle we're holding it. So I want to get this priority when we come back, though. That would be the only thing I would ask.
I know, and I know,
And there's the predictive routing as well.
I
am
understand
holding.
that we've been in that situation for a few cycles, right? That I think, well, I don't want to even say that, but I think we were expecting much faster progress in the review. But
I would suggest we proceeded in this way. So we wait for the BIS document and LispSec to go through, and then we start to move forward the other documents. Doesn't mean we have to wait until Montreal.
Yeah.
Awfully. At the same time, if we stand by a little bit, we hold on a little bit. It means as well documents like the young model will hold on as well. We can work on the young doctor, we will ask, but I mean, it depends on the energy of the working group. I don't want to burden anybody, but just that we agree on the how to move forward as a working group.
So if there is one lesson we have learned from all of this, is that all the proper review we will not be able to do now within the working group will come back with an exponential factor from the years.
Yeah. So honestly, the reason why I was I added it last minute is just I didn't want to lose a second cycle without actually doing an update. And I think it's important that we do the update so that you guys know that these are documents waiting in the queue.
This is Dino. So Fabio, there's no protocol changes to this at all. And basically, a host today can choose any EID it wants to, and the XTR learns about it. The XTR has no idea if it's a random number that's being generated, an allocated address from IANA or the registries or whatever. So, I mean, it does specify that this EID could be a crypto EID, a hash of a public key, and that more complicated stuff is put in another document that runs its own course. But this is just simply saying that a host could use any EID it wants and change it as much as it wants. All the machinery, Lisp machinery, doesn't know this is going on. It's just a configuration sort of thing. So it's a really trivial to review, right? Yeah. Now, the security area will probably say, is frequently changing EID secure enough, or do they need to be, those are the things they're going to, but those are much
This
more
should actually work in their
have,
direction.
We have 2 minutes. What I propose, if you want to gain time, what I propose is, what if we ask for a security review right away of the document so that we are sure that once we go over the last call, we don't have any issue afterwards. So it's like the young model. We try to gain time before we go for the last.
It won't work because it'll be dependent on the EID mobility draft and the ECDSA draft.
So you are saying we have still to wait? Anyway. What you are saying, we have still to wait anyway, because there is an interdependency between documents, Dino.
I don't know. I mean, there is
That's what you just said.
Yes. No. So no.
Yeah.
No,
I know what I said, but I'm trying to tell you what I mean.
I know what you mean.
I'm trying to anticipate what the sector guys would say. And if they just think that ephemeral addresses and changing things frequently is sufficient for these class of applications, then there is no dependency on those drafts. If they want something stronger, then there will be.
The most reasonable way to move forward, in my opinion, because of these comments, is we ask for a security review so that we are sure that once we move it to the ISG, we don't get stuck in endless discussion about the security, like we did with the BIS documents. And we really have 1 minute. Please go ahead.
So I understand everyone's concerns and willing to move forward. The first thing is that don't assume what a security review is. You said it will be easy. We don't know. Honestly, we don't know.
We say the same thing.
Yes, some experience, I would say.
I said exactly what the security review is unknown.
Yeah.
We don't know.
Yeah.
I mean, I don't know. Honestly, I prefer not to anticipate anything.
And I don't disagree with you guys about waiting, so let me be that bit clear. But
Now
Doesn't
they
mean we
have the
wait
right
until
content in their
Montreal.
mind.
Doesn't mean.
They are focused on this. We have a conversation with them.
Yeah, let's not discard them. I mean, I agree.
I mean,
they have also precious resource of the working group at this point. Let's
Okay.
not give them more reason to.
Okay.
okay,
The-
thanks everyone.
As I said, the time is over. So thank you for being here. About this last 3 minutes, what I gather is we will move the document forward in the sense that I will ask for a security review that we will not get stuck afterwards. At the same time, we don't go for working group last call right away. Okay,
No, but security review means involving someone from the SecDir. No, these guys are full. They have buffer. That buffer is full of Lisp requests. We don't want to add to that buffer. I mean, honestly, please.
I mean, it's not up to me to
Yeah, it's up to the working group, right?
No, to deal
Oh,
with
yeah.
the agenda of the SecDir. I mean,
Yeah, you can ask, actually, you're not going to ask Benjamin. for
No,
review, so
no,
it-
no.
You can click and ask for an early directorate review.
Yeah,
But as we all know, that's no guarantee that when it gets.
but we can try.
But it's good, and yeah, it shows that you're interested to get their feedback early. So I think
Yeah,
it's a
we
good
can
idea.
have a review for security,
we'll go to
guys. Doesn't
somebody-
mean we go to Ben.
You're not going to be. It won't take up time at AD.
The two people
Yeah.
that can provide feedback now are Ben. I mean,
Yeah.
meaningful.
Well, maybe you'll be lucky and Echo will get the review.
No, but
That's okay. Maybe I just over concerned about it. You guys think.
I think a little bit, and wouldn't be a bad idea if we give time to other people to get accustomed with Lisp so that they can review the security part. I mean, we cannot rely only on Ben and Eric, otherwise we will be always stuck on the pipeline of these two guys. So, I mean,
Has this been presented to security people at a certain point or not? That could be another thing to do, right? That may help involving people from outside this community. Yeah.
Exactly, exactly. But and not only on this document.
Eric, not Mark. I didn't see, so I wrote a draft called Privacy Issues in ID Locator Systems a year ago. I don't see it cited in this document. It might be useful to start there.
Okay.
Yeah.
Present the next list for review system. This is a draft review. No, it's fine. Rocket science is running for the most part. Oh, I didn't look at it.
Okay, if there are no more security concerns, we are over time anyways. Thank you very much for being here, and please sign the blue sheets if you didn't yet. Okay, see you in Montreal.
I'm sorry, I was expecting this for 2 minutes.
So, I mean,
No,
I would
actually,
love to focus on this thing, but I mean, this thing is
So,
really.
to tell you honestly, the reason I requested this long late, because I know how busy we are. I let it go one side already, and then I said, the second cycle, that's 6 months, that I'm not doing anything.
Yeah,